Doing a great job, by the way, Dan. Just so, you know, nimble excavation there. You should write that on your CV.
Oh, thank you.
Nimble excavator.
Hours and hours of practice.
Yeah. You know, the one with the ONC and the glass, that was a challenge. You know, that required mucho finesse.
Well, we found out that Dan has excavated an ROV-sized pit before.
Yeah, when we were recovering the Amy Maru, which is the Japanese fishing vessel that was struck and sank by the USS Greenville.
Wow.
We excavated for 2 weeks with 3 vehicles.
Wow.
And we had to make an ROV size excavation to get down and pass a big recovery rigging underneath the vessel.
Wow.
We had everybody on the boat dredging, cooks, deck crew.
I don't know if there's anything we can do while on the dive. It seems like the Ethernet to the still camera is being spotty.
I wonder if Bob took the clear cover off.
It's able to talk to it just fine. It's just it's essentially loses it.
Oh, okay.
And it won't allow us to control it because I think the connection's not quite good enough to the camera or to the actual computer that's running the camera.
If you you're talking to the NUC PC, okay though?
So, yeah, it seems like it. Well, it'll connect to it and it keeps on logging in. Like it should be able to connect. Like it's not the PC that's not behaving, but then as soon as I log in and I get the screen, it either kicks me out or won't let me do anything on it.
Yeah, that XRDP or that remote desktop thing, it likes a nice connection. You can't, there's no, you have to be remote desktop then to control the camera?
Yep.
I'm going to go ahead and write that down.
We could reboot it. I don't know if that will help. If you know the IP address of the NUC computer.
I do.
If you go to any one of these other computers around here and you pull up a command window and you ping that IP address, it should give you what the latency is. Our navigator probably has that technology. Our co-pilot does as well, but he doesn't have a keyboard.
Never good not to have a keyboard.
Yeah.
I'm not sure what machines you have in the back row there.
I would say let Tim get after it if possible. That's his bailiwick.
I just have to type ping, right? And then the IP.
There's a couple of us around here that know how to right click, Dave. I know you do.
What's the IP address that you're trying to? Or are you taking care of it back there?
Let me pull up the IP address.
Yeah.
10.1.70.something.
10.1.70.146.
Wow.
That's the instrument network.
That's what they all are.
If Tim's
here's
up here
Tim,
though,
yeah.
if Tim's around, that's.
He's now around.
What's that?
He's now around.
Tim to the rescue.
Packet sent, receive 4, lost 0. What do you need? What number are you looking for here?
The latency.
He's on it back there.
No, what's the
TTL?
Oh,
time 879 milliseconds.
yeah, that's
pretty good.
If you do, if you put a space -T after that ping,
yeah,
it'll ping away for a while, and then you'll get some average hits of what the latency time is. That exhausts my right-click capability. After that, it's all Tim.
Sorry, he's already back there. I'm just messing around at this point. If anyone's interested in what I'm doing, you can look at HyPEC plan. Take a look at those numbers.
That should be a double-digit number, I would think. So that front porch is approximately 1 meter. Yeah, so
Yep, you're on SPO.
stop it. Just gonna do a little more here and then we'll start another row or go deeper.
So the in the bigger picture, the dive plan basically is to excavate this, try to find material, and whenever we're complete here, or whenever we're complete here, to head north and try to find additional impact pits in the seafloor. I think that finding more pits based on the amount of material that's deposited here is a pretty forlorn hope. I mean, we can try, but I think we should take our time here, spend as much time as we can, excavate as much as we can. I think that's a more likely to meet with success than traipsing across the seafloor looking for more of these things. It was only visible because of the marks from the ROV. Does that sound reasonable?
Yeah. If you had a preference to dredge, so at this point, would I keep making the square more 1 meter by 1 meter, or should I start going deeper? Like I can do the whole camera area here, which is going to be close to 1 meter by 1 meter, maybe 1 meter by half a meter.
It's hard to, well, let's see. The little rover arm sweep that you're excavating now was probably in the middle of the original pit. I don't think we can see the original pit anymore. So
no, I've basically done the area of the original pit.
Where the
Of the original sweep.
Yeah.
Okay.
So I can keep going or go deeper.
Deeper is the goal. So whenever you're comfortable that you can dig deeper without the sides of the thing coming down into, go for it.
Roger that.
That was the problem last time, trying to use a little slurp sampler. It wasn't as methodical as what you're doing here. It was rigged for just collecting little samples out of the seafloor, and it was filling in as quickly as we could try.
Yeah.
Oh man.
Yeah. We've got the Venturi jet pipe going now, so.
Yeah, it's making a difference. Spectacular.
And even if the tailpipe fills in, we've left some area for it to escape around the hose, hopefully. So.
That was good.
How do we go on the stills camera back there? Any luck?
Well, we're working on it. It seems like we finally got the feed from the still camera in it connecting to the computer, but then the connection dropped out. So
Copy.
things are going, but not great.
If that all goes south, I have a Raspberry Pi with a camera you can stick in that fancy housing.
Oh, it's one of the nice things about bringing a big enough housing is we can put all sorts of stuff in there by the end of the cruise.
Put an array of GoPros on that lens.
I'm so putting one of those housings on my Christmas wish list. Maybe they'll give me a discount since we're neighbors.
I'll bet they do. Or depending on how good of a neighbor you are, maybe they'll charge you more.
Yeah. Uh-oh. Sorry, I pressed a button here inadvertently. And stuffed the nozzle while I looked away.
This reminds me of one of those little Zen sand gardens.
All right, so I'll provide some little update for the website. Folks following along on the Nautilus Live website. We have, for those of you who are just tuning in, basically we are looking for meteorites from a meteorite fall which occurred in 2018. We are off the Washington coast in the Olympic Coast National Marine Sanctuary. This was a meteorite fall which occurred into the Pacific Ocean, a few tens of meters off of the coast. After 4.5 billion years in space, it landed in the ocean. On a previous dive with Nautilus, only a few months afterwards, we found a circular impact pit in the seafloor. At the time, we weren't sure that's what it was. Any little circular feature on the seafloor could be some kind of animal burrow or probably the last thing you would think out of a little thing on the seafloor is that a meteorite plunged out of the heavens and made it there. So we collected some material from this little pit, and in the year and a half, almost 2 years since then, it actually has been 2 years. We analyzed the samples at Johnson Space Center in Houston, Texas, NASA Johnson Space Center, and it amounted to very carefully sifting through all this really fine sediment. We found about 150 tiny melted pieces of meteorite, and this is from a set of 9 separate samples taken at different spots through the strewn field, the area where the meteorites were seen falling into the ocean. So we collected these 9 samples and found a bunch of little pieces of melted, very small ones. We're talking less than a millimeter. But the vast majority, most of the ones we found came from that little circular pit. So we're back now. It's probably 70% of these things came from the little circular pit. So we're back to this revisiting the site of that circular pit to try to excavate down and find what actually made the pit on the seafloor. The original pit was 60 to 80 centimeters across, and so the original object embedded itself in the seafloor. We have what you're looking at on the screen now is a methodical dredging of or removal of sediment at the impact site. The circular feature was no longer visible because you can see all the debris in the water here, the marine snow which constantly sits. But the footprint that the ROV made when it landed on the seafloor was visible, and so was the original little sampling trench that where back in 2018 we removed material from the pit. So we rediscovered the landing site, methodically digging our way down. What we're hoping to see here is images of a large rock emerge in the sediment. Remove the fine silt here. What's going to happen is we're going to dig this pit deeper and deeper. Hopefully it stands out. Either way, there is a large magnet, portable magnet on the front of this the ROV. And when we get to the point where we're happy with the depth of this hole, we'll take that magnet and stick it down into the hole and try to extract the meteorite or pieces of meteorite that are down there. This particular one appears to be, well, it is very rich in metal. This is a somewhat unusually metal-rich type of meteorite. The exact identity, there's dozens of different types of meteorites. There's about a dozen, maybe less, that are metal-rich types, and we will find out exactly what kind it was by getting larger pieces. And
Thank you for the synopsis.
Yeah.
Oh yeah, well,
I had like 3 questions and they were all answered.
Outstanding. Have we got any more? Bring it on.
Yeah, were those? I'm just looking through some of the photos from it. Was that from? It was the majority when you said it was from one sample. Was it through the scooper that had the bag attached to it? Was that where they were mostly found from?
No, that was this was samples taken with the slurp sampler. We kind of very carefully slurped up some of the sediment and trapped it in a jar, and then tried to excavate a pit like this, and it didn't.
Okay. I'm just curious if the pit that we're excavating right now was the footprint of that scoop. Just I'm looking at photos and looking at where the Herc footprint was and where the scoop was and how we're oriented kind of 90 to it. Kind of looks like maybe we're on the scoop site. Do we have a proximity from where that scoop site was to the slurp, or was it in the same location?
It was right there in the middle. That should have been right in the center of the pit.
Okay, so you think that we slurped and then just did the scoop right through the middle? Is that right?
Oh, it wasn't the scoop. It was just extensive slurping that.
Okay,
that
yeah.
Stirred up.
So I'm just wondering if the site that we're slurping up right now was actually the scoop site, just based on the way that looked when we first approached it. Hard to say. But I'm seeing a photo from the cruise that we were on, and it's got a Herc footprint and a scoop mark oriented very similar to this one that we approached.
You're saying the thing that we found was probably the scoop area?
I think it may have been. I don't know. It's hard to see what the photos of the slurp area would have looked like, and if it would have looked very similar to what.
He's saying the slurp and the scoop were the same place, weren't they?
The slurp here at the little impact pit was site number 6.
Okay.
We used scoop at the very end for the 9th sample, and that should have been farther to the southeast. But you got me curious now.
Oh no, that's fine. Farther by how much? Just want to double check.
It was. Let me give you an answer. Hold on.
Yeah.
It should have been tens or 100 meters or so.
Oh, okay. Well, then we're not in that location. I was just, trying
verifying.
to piece together these photos and see if we could learn anything from that. But
oh yeah, no, good question.
Let's take a look at some of the slurp.
We had a slurp sampler. We had a this array of magnets that it was like a Teflon device with a series of magnets all bolted to it, and also had the scoop. The magnets, it was just, the idea was you put this magnet down in there and try to pick up metallic pieces of meteorite on the seafloor. And the first time we put that thing in the seafloor, I picked it up and showed it to the camera, and it was just totally black. It had picked up. Turns out the sediment here is apparently the parent material was all basalts, and from all the volcanoes on the Washington coast there, and it has left behind a great deal of magnetite, and it all sticks to the magnet and fouled it. So that's why the magnet that's sitting in the front of the ROV now. We went and got a switchable magnet, which should be able to put it down in that hole. Everything will stick to it, and then switch the magnet, and it physically retracts the magnet from the face of the box that it's in, and hopefully all that stuff, all of the magnets, will then fall off into the collection box. Anyway, there's the magnet, the slurper, and the scoop. And let me get you an answer on how far away the scoop was.
Ooh,
It's okay, I can
got some
actually,
company.
I think I'll be able to plot it out actually. I can just, I have the target for 006, and that's the sample you want, and that's pretty much where we're directly over. I just wanted to make sure that none of the other targets were in super close proximity, so we weren't getting that mixed up.
Understood, thank you.
Yeah. See if I can find that and plot it up.
So we determined that that scoop would have been further away.
I think so. I'm kind of looking
Yeah.
through the targets
Alright.
right now.
Yes, here we go. All right, I found it. And it was 007, not 006. And it was 138 meters to the southeast.
Roger that. And then same with, okay, 5. I'll try to, I can plot these up actually.
Yeah, 5 was a similar distance to the northwest.
Okay, that sounds good. And this likely was it. I don't see anything else that would have caused that kind of.
Yeah, sample 5 was 215 meters to the northwest.
Roger that. Okay. It's good to double check.
Yes, absolutely. Thank you.
Thanks, Detective Nav.
Yeah, I just, you know, I'm not doing much navin over here, so might as well go through old photos. And...
Play with that
Get
Norbit if you want.
Oh yeah, the Norbit. Okay, I'll do that.
Yeah,
Well,
Norbit.
you ready? Are you okay with the ground
Yeah,
fault situation?
Yeah.
Okay.
Turn on the Norbit for him, Mike, please.
Turn on number I.
Orbit.
So what do you call a scientist that studies impacts?
I don't know if this is a joke.
What's that?
It's straightforward. Impact scientist.
Impact
Oh.
scientist.
Insert joke about making an impact in your field here.
Ha ha ha, waka waka.
Yeah.
Did Norman not go on?
The Norbit is not on. You would see a associated DCGF.
It's not turning on for me.
Maybe you've got funny business on your Argus.
I believe I might have some funny business on my Argus
Yeah,
GUI.
maybe we have to try it on her GUI.
Am I cool to touch your touch the screen to turn it on?
Sure. If you have it on your screen, it should go though.
Yeah. Oh, maybe it's just not turning on.
Ruh-roh.
Well, why would that be, Michael?
Yeah, it doesn't want to turn on.
The Ethernet bottle must still be on.
This Ethernet bottle is on. The spare power's on. I didn't turn it on.
Spare power should not be on.
The 24. Oh, that might. I think that's the. I think according to my GUI, that's the camera, the still camera.
Yeah, it could be. Probably is.
But yeah, the orbit is not turning on.
Roger.
It's odd it was on.
Which is weird, yeah, because we turned it on earlier, right?
It's because the GUI is locked up.
GUI is locked up.
Yeah, that's not good. Can you turn the porch light on or off?
That is a negative.
All right, Tim.
Deploy the TIM.
That's gonna require
Tim's coming down.
yeah, standby.
And mine too, if it's different.
Okay. Delayed.
Belay, belay.
Does this connection dialog come up when you power it on? So I could close this and it'll pop back up when we power it on, or do I have to leave it on?
Basically, what I worked out, you had to close the program,
Gotcha.
but
Gotcha.
I spent maybe 10 seconds. I read the directions and
That's fine. I will close it.
we had it running at pre-dive just for a heartbeat.
Come on, meteorite. Where are you?
I'm over here.
Oh,
That
they
would
are.
be if only.
I think I heard it.
They're extraordinarily fickle. Finding meteorites is it's difficult work on land.
Is there a more typical a typical, what's the word, composition that
Yeah, so meteorites come in a variety of shapes and sizes. Your typical one. All right, let me back up. The range of different meteorite types available to you in the great cosmic meteorite. I hate to say market. That's not right. Anyway, the meteorites are there's. I'm sorry, it's really early in the coffee. It's not picking yet. There's three major types of meteorites. There's if you depending on who does the describing, there's three classes. There's the stony ones, the iron meteorites, and the stony irons, because I think they were completely as short on coffee and descriptive terminology as I am right now. There's a simple version. There's actually several dozen types of meteorites when you get into the nitty gritty of it, but that does the trick for a broad description. Most meteorites are stony. And they're basically exactly what it sounds like, different types of rock from different asteroids. Your meteorites come, as far as we know, pretty much exclusively from asteroids and not comets. I can get back to comets later. But the stony meteorites are coming from the outer crust of larger meteorites, larger asteroids, or can come from anywhere inside of smaller asteroids. Okay, I got to explain that. So way back, 4.5 billion years ago, when the solar system was condensing out of gas and dust, basically you had a series of steps where you started condensing little droplets into rock, and then those little droplets condensed, aggregated into larger and larger bodies, and the larger bodies aggregated into the planets. That's the simple version. The rubble that was left over from that process is the asteroids. Basically, the real science value out of studying asteroids is that you're seeing stuff that's left over, most of these things, left over from the formation of the solar system 4.5 billion years ago. That process that ended in planets. Some of the asteroids are younger than that, or some of the meteorites are younger than that, but that's kind of a different story. The big picture is that you created a range of asteroids of different sizes. The very smallest ones basically kind of aggregated, cooled off a little bit, and have been more or less the same for that 4.5 billion years. Various things have happened to the asteroids, but they're more or less more than less a relic of that aggregation process 4.5 billion years ago. The larger ones, if they got to a large enough size, they basically could kind of internally heat themselves to the point where some of that rock started to melt. And it had to be a fairly large asteroid for this to happen, large enough that it kind of collapses into a sphere under its own gravity. You look at the asteroids today, and the little ones are all kind of irregular shapes. The handful of largish survivors are spherical. For example, the largest asteroid in the asteroid belt is actually, they've classified them as dwarf planets, but the largest one is Ceres, and Ceres is about the size of Texas, and that's as big as it gets. So in these larger ones, you could, they basically heated up internally, from best we can tell. That heating was mostly from radioactivity of some short-lived isotopes in the formation of the solar system, and it heated the interiors of these things to the point they melted. And when they melted, then the original material was stony. It was kind of a mixture of rocky material, silicates, and metal, and some sulfides like pyrite. Fool's gold is a sulfide. And when you melt all that, the heaviest stuff kind of sinks. Well, it does sink. That's how it works. And so you melt the whole thing, and all the metal and the sulfides sink down into the center and form a core. And the silicates that are left over kind of float up and form a crust. And so, and that's the general composition of the Earth today. We have a metallic core deep inside the Earth. We have a molten mantle, and then there's the solid crust that we walk on. So something similar happened in some of the larger asteroids during this period. The reason I'm explaining all this is because, like I said, the asteroids are kind of leftovers of that process. So you're left over with a bunch of little ones that never got big enough to melt internally, and some larger ones that did and formed a crust and a core. And so asteroid belt, where most of these things come from, is a kind of a wild and woolly place. And you get collisions periodically. You get material stirred up out of its nice, fairly stable orbits by the passage of the planets or interactions with one another. And so you end up with asteroids or portions of asteroids, little smaller meteoroids directed inward into the inner solar system, and they cross paths with Earth, and these things come plunging out of the sky. So we are meteorites are giving us a sample of
I'm off
all
of
of these
SPL,
different,
that's why.
the small ones and the large ones, and we see that mix of compositions in the meteorites. So a very, very long, drawn-out answer to your question is most of that material is from asteroids that were never big enough to melt, and so they are what's called the ordinary chondrites, and they're still a mix of silicates, of rocky stuff, of little bits of metal, and little bits of sulfide. And that makes up most of what falls to Earth, or at least what survives as meteorites. Wow, we got a fish. And that is the sum of my knowledge in biology.
That was all very interesting. Thank you for sharing.
Sorry, I got distracted by the fish. So most of the meteorites are the leftovers from the little bodies, but some of them are fragments of the larger ones, and that's where you get the basically, if an impact is large enough to break up one of these larger bodies, then you expose the core and throw chunks of the core into the inner solar system, or there are at least stuff from deeper down inside these larger bodies. And that's where you get meteorites that are, some of them are entirely composed of metal. Those ones are really interesting because they are they come from the cores of the larger asteroids that not only were large enough to form a core and a crust, but later on something very violent happened, completely broke it up. And you're looking at the scattered remnants of some large. So it's not just an asteroid that was large to begin with, it's one that's probably been completely destroyed. And those make up a small percentage of the total number of meteorites.
Do we have a kind we're hoping for here that would be most interesting, or to you guys?
So, well, they're all interesting one way or another. They're basically a bunch of puzzle pieces, and all these puzzle pieces are raining down. And you don't get the big picture by having one or two puzzle pieces. You get the big picture by putting a bunch of them together. So, with meteorites, more is better. Every time we get a sample of something new, it is valuable. It's not just another something that we've already seen.
So is it more fun to meteorite hunt in the ocean or on land?
Well, I tell you what, my big worry here was being able to find this spot again, and y'all made it look easy. So now we're into the fun part as far as I'm concerned. I can quit being anxious about it. I have searched for meteorites on land a few times. I can't say I'm terribly good at it, but I've gone to meteorite falls in the U.S. and helped look for meteorites. Emphasis on look. I didn't actually find anything. But to give kind of some perspective, meteorites show up on weather radar, and this is something I've been doing for, geez, about the last 13 years or so now. And basically finding meteorite falls on radar. And in the, let's see, where are we at now? About 30 years worth of radar data that's archived. There are 25, I believe, we're up to different meteorite falls for which somebody actually collected a meteor.
Sorry, what was that, Nev? No, I'm now on data again. We fixed that comms issues. Sorry for cutting you off, Dr. Freeze. So how's this? What are we at right now? Where do we stand?
Yeah. So we have an issue with our topside control system, and we're going to do a highly technical maneuver called a reboot.
Yeah.
Depending on how long the reboot takes and how quickly we regain control of the vehicle, we may come off the site here. So when the vehicle's light, it may float up, and if that happens, we're going to move the ship to keep Argus and Herc separated.
Yeah.
So if all goes well, you guys won't notice anything except for a pause. But if you see us moving, then we'll try and regain control, and we'll come back to the site. And if it goes, if that is not possible, we'll execute what we call a dead vehicle recovery. So that's the worst case scenario. In which case we'll just keep moving the vessel.
I'd just like you to stand
tow
by.
Herc around for a
We
while.
may have to move the vessel, but if you could just stand by for a minute, I appreciate it. Thank you. Okay, bridge is standing by.
Roger. Are you guys okay with that in the back row?
Yep.
Yeah, that sounds good.
Okay, here we go.
Do your thing.
Looks like the other one's Herc Atalanta.
Hey, Ryan, are you on SPL?
Sorry, Mark, who were you asking for?
Yep. Ryan Ziegler is calling you. We will stay off the line, let y'all work though.
We would expect to lose.
Don't mind us over here, ROV. This is fun. I think that it should be right about here. That is very fun. That's the least fun one. That one's the most fun. Oh. So video, can viewers at home, when we're drawing on the telestrator, can viewers at home see what we're drawing?
That's a great question.
Okay.
They can?
Oh, you want us to try? All right.
And Mark, that's also a question for you. Can you see any of that on the video screen? We're making line drawings.
Okay, let me check. I only have the front end video up. Give me a second.
Yeah, according to our satellite feeds, you cannot see
Michael,
the telestrator.
just leave it
Okay,
alone.
so that's
Michael.
private.
Okay. Michael, stop. We want to test the situation.
Copy.
Have control of the vehicle, all good? You have frozen images right now? All right. On Nautilus Live, you can. Video, are you hearing this?
At the top of.
Oh, the hand-drawn images. Okay, I see. No, he did not. Did not see that. So Dr. Fries, are your images frozen on what you're looking at in general? All right, video is aware.
Yeah, copy that.
Great. Okay, copy that. Thank you for your updates. We're working on it, I believe. I think so, yeah. Oh. The ROV
Have you
sitting on the
refreshed
ground.
that? Or there may be a play button you can see. Good.
Front row, we still troubleshooting?
Just wrapping that up right now.
I think we're good.
All right.
I needed to reposition the vehicle anyway so I could see more of the giant trench that we're digging.
Bridge nav.
Thanks to some pure magic from our data engineering
We're okay
department,
to
we're
hold
back in
position here,
business.
so thank you for standing by.
Tim is awesome.
Yeah, I can live without the Grafana thing for a while. Or let Tim poke it, but no, that's good.
Okay.
All right, we're back.
All right. So how deep do we think this is so far?
Well, looks like it came back.
I'm gonna do a slight adjustment of my grip here and I'll be able to give you a better idea.
And how much has it filled in with the turbidity since we left?
Not to mention the fish swimming by and filling it up.
Yeah.
Oh, what a jerk.
Don't mind if I just kick this in there?
There. Okay, I can see it again.
Okay.
All right.
All right, is our dredge still
That is a very
jamming
good
at 100%?
That is a very good question, and it looks like it is.
Roger that.
Want me to cycle it? I'm gonna cycle it.
Video, you want to zoom in a bit there for us?
Yep. I'll go for the real cinematic zoom here.
Yeah, you can zoom out a bit there. That's perfect.
Is it picking it up?
So the lasers are
10 centimeters?
I thought they were 4 inches, but I'll settle for 10 centimeters. So the dredge nozzle is probably, I don't know, 6 to 8 inches long.
All right.
So does that give you a scale there?
Call it a foot?
Yeah, maybe 300 millimeters.
That's about what, 30 centimeters?
Something like that.
Approximately.
So we're back in business.
All right.
What do I do with my camera here? Sorry, don't mean to make you dizzy there. We're shallow, so the camera's super fast.
I think you racked out the you racked out the starboard
nice
bin.
Feature.
Yeah.
Your
Was
rack
that
is
you?
set to,
I didn't do anything.
yeah, his rocker is set to the starboard bin, not the,
Really?
there you go. Yeah. So then you change the rocker switch up above there. That's probably changed.
Thank you, Ernie. How did that happen?
Probably because of the
I need
topside
to,
restart.
sorry, I need to push some buttons here. Standby one. Oh, I hate it when it does that. Okay.
Yeah, I guess the topside reboot. Change that around for you.
I got a few other things to adjust here, just stuff we usually set when I'm on the bottom to went away in the reboot, of course. I think that's it. So we backed up a bit and landed slightly off heading there. I think our original heading was, what did we say our happy current heading was? 150-ish? 140?
Yeah, 140. That's what you said.
So we're 5 degrees to the left of that now.
Yep. Makes sense.
That's looking sandier to me. It's good.
Oh, got a
Shell.
lodged shell. Powerful slurp. Picking up that
Wow, it's
shell.
a big shell. I'm guessing there's not a meteorite under the shell.
Otherwise, we got some explaining to do.
Maybe it was filtering through the sand and it like put all the pieces back together.
Maybe the meteorite pushed it down there. Hey Mike, I got something you can do.
Yes.
You can switch back over to the Herc GUI there and you can bring that little text window with the top side. Make sure you don't close it, but drag it over into the open area of the screen there so we can monitor it.
About your Grafana.
Yeah, so now, yeah, there you go.
There.
So my feel good screen there.
So it must have just crashed in the background.
Now it's going to be like forever.
Why don't you readjust the Grafana window so it doesn't go into the background? So drag it up from the bottom, make it not as tall.
It's a pretty strange looking shell.
That way it'll be easier to hand over to the other crew.
I keep seeing things that look like chunks, but I just don't know if they're chunks of
Is this okay with
dirt.
you?
What's that?
Is this okay?
Yeah, perfect, thank you. That's how we're gonna roll from now on.
Yeah.
You've set the new standard, Michael.
Great. Now, now another thing to put on the Grafana.
Yeah. Well, Michael, you did point out that the top light did turn to red, but I don't know when that happened. Or
I didn't know when it happened either, but I noticed that it did. The moment we were like topside, and they're like, oh.
What light turned red?
The top light.
Herc Argus top. Yeah, that third light. That's
indicating
green.
that the topside
It was red.
was red.
When did you point that out when I obviously wasn't listening to you?